Oh, hi. My name is Ram Posham. I'm a strategic client executive architect with Oracle for many years. Today, I'm going to show you something very interesting, very exciting. So I'm going to be creating a primary database in Virginia region. And then after that, I'm going to create a standby database in Phoenix region just by the UI of the OCI. All right. And you will see how easy it is to create primary and standby databases, basically to uh, deploy these databases in maximum availability architecture. All right. So let me just quickly show you what I have done. I have created, in Virginia region, IAD, I have created a VCN with a CIDR block of 10.0.0.0.16. And using the wizard, when you create, it creates two subnets. One is the public subnet, other one is the private subnet here with 10.0.1.0.24. All right. And by the way, I already have a bastion in this particular public subnet. I'm going to be using that for connecting to the RAG database and doing some tests. Right. From here, I will be connecting to the RAG database here, and I will be also connecting to the RAG database here. So I will show you everything. And then I also have a VCN in the Phoenix region. And notice that change. Here it is 10.1.0.0/16, whereas here it is 10.0.0.0.16. All right, that's the difference. And here I got two subnets, one the public and the private. I'm not showing you the public subnet here. I'm just showing you 10.1.1.0.24, which is a private subnet. And this is where we are going to be creating the RAG database, standby database here. All right. And before I create the standby database, actually, I need to peer these VCNs. I should be able to communicate from this VCN to this VCN. Otherwise, you cannot create the standby database here. All right. So there is a small video, about 25 minutes video, long video you can watch, and here is the link. All right. And so this will tell you how to create a dynamic routing gateway in Virginia region and another dynamic routing gateway in Virginia region, how to attach them to the VCN, and then same thing on the Virginia in the Phoenix region. Then they are going to be connected through RPC, remote procedure call interface, right? So that's how they are going to be connected. But yeah, I strongly recommend you to watch this YouTube video to understand how VCNs can be connected so the traffic can flow between these two networks. All right. Then before I create the primary RAG database, here are the security lists that you need to configure. All right. When you create a VCN, actually, for the private subnet, it creates 3 security lists, right? So, for example, this one, say SSH, and it allows ingress rule. This is the ingress rule. It allows SSH traffic over port number 22, and then ICMP, and the second one is with codes 3, 4, and the third one is 3. So these are the things that allow with these rules. And by the way, these are created by default. Whenever you create a VCN using the wizard, it creates the public and private subnet. For the private subnet, these are the default security lists. Then for creating the RAG database, you need to have the ability to have SQLite traffic over port 1521. So the RAG nodes talk to each other, and you need to have that port number 1521 open. Actually, there is a scan listener, and there's always communication going on. So you need to have that 1521 port opened, right? So that's what this one is. So allows connection traffic from client and a public subnet required. So if I want to connect from my public subnet here, where I have the bastion, that's why I have this 1521 port ingress. So I'm allowing ingress traffic to all the subnets in this VCN. So that's why I'm using 10.0.0.16. The second one is Oracle notification services. That whenever you create a RAG database, there are ONS infrastructure, right? The Oracle notification services infrastructure. And for that, we need to have port 6100 opened. So that's the ingress traffic within the subnet, right? 10.0.10.24. So that's what you see here. Then this is another very important one, actually. So we want to have ingress traffic allowed from 10.1.1.0.24. Sorry, that one is from the private subnet in Phoenix region. So when we create the RAG database here, this has to communicate with this database here. So that one is required because when you have a data guard set up and when you do switchovers, failover, the traffic is over 1521 port. Basically, when you run DGMGRL or SQL Plus for switchover, this is what that port has to be open. So we are allowing the traffic from this side, from Phoenix region. All right, so that's the one. Then the next one is ICMP. This is for just ping traffic. So if you want to allow ping from Phoenix, so that's what I opened. Then the next one is 10.1.1.0.24. I'm allowing SSH login to the rack nodes from this side, actually from Phoenix region. Well, I'm not really going to be using it, but just in case I am on Phoenix region and I want to SSH to this rack nodes, I should be able to do that. So that's the thing. 10.1.1.0.24 is the private subnet here. And from here, I'm allowing SSH traffic. So that's pretty much it. Then now we are going to create the RAG database, all right, in this subnet. So let me show you that, how easy it is to do that very quickly. So I logged into my lab account. So go here and say I want to create a RAG database. I already chose my compartment, and the RAG database is going to be, I would say, sales IAD, right? Sales IAD, I call it, and it's going to be virtual machine based. And here, what is the shapes? By default, it gives you 4 core, 64 GB of RAM, but I don't need that actually for my lab. So I'm just going to reduce this to 2 cores, and then by default it allocates about 256 gigabytes of usable space. So total space allocated is 712 gigabytes. So for my lab demo, that should be plenty. So I'm just going to, and it requires SSH keys so that we can log into the rack nodes. So let me do that. And so this is where I have my SSH keys. So 2021-11-28 is my public key. So that's what I'm going to be using. And then I need to use the, obviously the network, right? So I have got the, actually this, I want to do it in Ashburn first. So this is very important. So I want to first create the RAG database in Ashburn. So let's go up here. So this is where it is. So, okay, good. And then I want to create a 2-node RAG database. So that's the 2-node I picked. Oh, I need to change the shape also to 2 cores. All right, so I got 2 cores and 32 gig RAM because I changed the region. So I have to kind of start all over again. Sales IAD, I'm able to do in 1, and then 2 nodes. This is the amount of storage that is allocated, and the cluster is, I can say RP, or actually because it's optional, so I will just leave it there. Then I'm going to upload the key. I already uploaded the key, and I'm going to use BYOL, and I need to pick the network. So that is going to be VC and IAD. I already have that, and the subnet that I'm going to be using is the private subnet. So that's a private subnet, And I'm going to prefix my host as IAD, RPIAD. So what it will do is it will create a node with RPIAD1. The second rack node will be RPIAD2. And of course, it's going to add this suffix for the complete name, what we call fully qualified domain name, right? And then, so I'm just going to leave the defaults. So show the advanced options here. I can change the time to New York. Maybe let me do that. Then choose the fault domain. If I want to, I can do that. Let me go to the next one. I'll say my database name is going to be, that was the previous one of the display name. Here is the actual database name, sales IAD. Okay. And I don't need to use any suffix. Actually, let it assign. It's going to assign a suffix. It's going to dynamically generate a string, and it's going to suffix to this particular database name. All right, DB name is sales IAD, and it's going to choose by default 19C database, and it needs the password for the sys. Put in the password here. Then by default, it enables backups. I don't need backups. This is just to demo. Then that's pretty much it. Actually, there was a place to enter the PDB name. Oh, here it is, the one. So I would like to enter the PDB name as sales. So my database name is sales IAD. This is a container database within which I'm going to create a PDB called sales, and I enter the password, and it's going to use the TD password. All right, it's a TD wallet, so it's going to be stored locally on the cluster nodes, and otherwise I can also use Oracle Vault. So, all right, so here it is. Okay, and actually this is the use the administrator password for the TD wallet. So to open the wallet, you're going to use the same password here. All right, and then I'm going to create the database. All right. So it's going to take about an hour and 30 minutes. And until then, I don't need to record. So I'm going to pause. And so let me pause the recording. Oh, hi, this is Ram again. So let's see if our database is created. Continue the lab. So here we go. I have this sales IAD database, and let's see how long it took to create the database. It started at 1928. This is the UTC time, by the way, and it completed at 21. So it's about an hour 30 minutes. All right. Yeah, it's just about an hour 30 minutes. So now let's connect to the database and create a schema. Right, that's the next step. So we created the rack database, and we are going to connect to this through this bastion. So let's how do we do that? So let's so I have a nice spreadsheet. You enter the IP addresses, and it generates actually all the commands. So my bastion is here. So I'm still in a Ashburn. So my bastion is running in the public subnet. See, this 10.0.0.42 is the private IP, but there is also public IP for that. So that is 132.147, 145, 142, 147. So that's what I entered here. Then the DB name was sales IAD, correct? So let's go to the DB name. So the DB name is sales IAD. So let's just copy this and paste it here. And then a unique database name. So this is the unique database name. Just copy this and paste it here. And then we have this is the primary, but the standby we have not created the standby. So instead of just leaving this one, so let's So let's call it sales sales PHX for now, and the PDB name is sales. You know that. All right. So for example, here the sales ID and the PDB name we created was pluggable databases. See, that is the pluggable database name. And then okay, so this is the service. Sorry, this is the default service that actually Oracle creates for you, and this is the service that we are going to create with this actually suffix. So I'm going to create a service with this name. And what is the primary rack node IP address? So let's go back. So here are the two nodes. So this is the primary rack node IP address 1. So just copy paste that. Should be no space here. Then the second one is this 208. Paste it here. Then we don't have the IP address of the other ones because we are not created the standby. So for now, just enter N1 1. Let's enter 00, or 1. Well, actually, we are going to change it, but I just didn't want to leave them as blank. Then primary DB scan name. So where is the scan here? Here is the scan. So copy this and paste it here. So that is the primary. The next one is just copy the same thing for now. Just change it into PHX. We are going to get the actual name there later. And the port number is 1521. This is the service name. This is the sys username, password that I entered at the time of creating the database. And this is I'm going to create the schema as order entry schema of size 0.1. This is about 0.1 gigabytes. This is the table space name. And I'm going to create a configuration file for swingbench later. And these are how long we are going to run the swingbench later for when we run the OLTP workload. And this is going to be the configuration file name. But for now, let us just create the swingbench schema. So this command is actually generated when I entered all the input here. So just to make it a little interesting. So copy this, go to open a bash shell. So paste it here. So I logged into the bash shell, you can see. Then what we are saying is you just copy paste these commands. It's going to download the swingbench and install it. Okay, so actually this is just this is what it's going to do. So paste that. See, paste it here. So it's going to download swingbench and unzip it. Then, so what we are going to do is we are going to log into rack node 1 on the Virginia side, IAD side, and we are going to create. This command is actually created for you based on your input. All right, this command, everything is, for example, the service name, we call it sales here, right? Sales.tac. So create a service, add service minus DB. This is a database name. Service is sales.tac. So this whole command is generated for you. But for now, let's log into the. This is so another window we need to open. So go create another bash. So in the previous window, you remember we actually created a SSH tunnel. See this one, this is 10.01.108.22. This is the SSH tunnel to that. So here we are actually going to log on to that particular host. Let's see. Okay, here because of I'm repeating this demo. my local host file, known host file is having the previous address, so I need to edit that. So local. So, okay, now let me run this command. Yes. So this is the host name. See, this is RPIAD1. That's my rack node. So then what we are going to do is we are going to create that rack database service. So this is the command. You just copy and paste it. All right. In this window. So first time it's not there. So it's going to create a service with the name sales.tac. That's going to span across those two instances. All right, so it's done. So sales tag is running on sales IAD instance 1 and sales IAD instance 2. That's the second instance. So then we are going to create, I'm going to go back to, this one is, sorry, this is the rack node 2. If I have to log in, but I don't have to log in there. So go back to this one. So what I'm going to do is I'm going to create this is a standby instance. So we are going to create a service name on standby instance later. So for now, I'm going to skip this. This same thing if I want to log into rack node 2 on the standby side. Now I'm going to create tnsnames.aura on my Bastion node. So this is also generated, by the way, for you. So just copy this and go to this one and paste it here. So the tnsnames.aura file is generated and the tns admin is, variable is exported. So now if I want to list the databases, I can just copy and paste these commands. It's going to use that tnsnames.aura. So it's going to see it's connected to the primary database, and it says, yep, this is the PDB. And then you can, if you want to check the services, you can do that using this command. Then you go to this one. See, the first one, you create SOE schema. So go to the Bastion window and just run this command. Swingbench bin directory, which we installed a few minutes ago, and run this OE wizard, right? So just copy this command again. This is generated for you. So paste that here. So it's going to connect to the container database is PDB, sales PDB, and it's going to create the schema. So within less than a minute, it's going to create the schema with about 100,000 customers. And so I will show you that. And there are other commands. If you want to run them, you can see whether the schema is valid and all that. So I'm not going to run them, but if you're interested, you can use these commands to check the schema validity. What are the tables, the constraints, everything you can check here. All right. Actually, you know what? Just let me run this command to show you what this schema is all about. So it just tells you, see that it has got all these tables, inventories, orders, customers, 100,000 customers, and so on. So this one is what? I cannot read this color, but are the keys enabled or disabled? So that's what it's showing you. Right? So good. Okay. So now what we are going to do is we are going to create the we already created the SOE schema, right? So now what we would do is we are going to actually create a OLTP workload. We can do that if you want to, but maybe, okay, let's do that. So I need to create the configuration file. So that is the configuration file I need to create. Very quickly, I'll show you that. So go to the Bastion window again. So it creates the swingbench configuration file, and here I have the OLTP workload. So it basically makes about 20 connections, and we are saying run it for 5 minutes. I'm not going to run it for 5 minutes, but just to show you that. So this is a character mode swing bench. So it's going to create 20 connections, and after all the connections are established, it's going to actually insert customers or insert new orders and so on. So that's what it's going to do. And so let's see. It's going to start in any second. So, and this is a swing bench, I think some internal error, but anyway, you can see this is the transactions per minute. This one, the first one, this is the number of users, transactions per minute, and this is the transactions per second. And now we are going to create this is my database. All right, and you go to the data guard configuration, and here you can say enable data guard. So now you can say display name is sales PHX, right? And that's going to be the sales database in Phoenix, and you choose Phoenix region, and the available to domain is, you can choose any available to domain you want, and change the shape to, let's match the shape, just have 2 CPUs and BYOL, and here is the virtual cloud network VCN1 Phoenix. I'm going to choose private subnet, actually, see that private subnet, and the host prefix is RP PHX. So that's the Phoenix. All right. And then I'm going to create active data guard and maximum performance, and go to the next one. And it's asking for the database password. This is the configure standby database password. So that's okay. So enable data guard. So it's going to take about an hour, 30 minutes again. It has to install the database software, and it has to create the standby database. All right. So that's what's going to happen. And so you can see, so it's work request. See, it's a create standby database. It just started now, and it's going to take about, as I said, 1 hour, 30 minutes to create the standby database in Phoenix. So for now, what I would do is I would stop this, and then after this, I'll create another video to show you how to switch over, how to fail over, those kind of demos. I'm going to show you, okay? But thanks. Let me stop here. Oh, hi. This is Ram Osham again. So let's see what we have done so far. Basically, we created 2 VCNs, one in Virginia, other one in Phoenix. Then after that, actually, I also configured what's called VCN peering. So my goal is to create a primary database in Virginia and a standby database in Phoenix. And for that communication to happen, these VCNs, VCN1 in Virginia and VCN1 in Phoenix, the resources need to communicate. And for that, there is a need to peer the VCNs. So there's an recording on, the link is provided here. You can watch that. The next one after that is we need to set up these security lists before we create the standby, before we create the primary database. So I already went over this in my other video. So these are some of the key things that you need to do. Then after that, you need to, before you create the standby database, you need to do the similar thing for the VCN in Phoenix. So these are the security rules. For example, I want to be able to do SSH from this bastion from here, from this bastion here onto these resources. So that's why I had to set up this SSH rule to create SSH session on the rack nodes on the Phoenix side. All right. And then this is for we need to set up the SQL, the rule for SQLnet traffic, because when we do switchover, that happens over using SQLnet, right? So that's why we are saying the source is 10.0.1. That is here 10.0.1 is a private subnet, and we need to allow SQLnet traffic. So that's the one here. Similar 10.0.0.24 is the public subnet, because from this bastion, I want to, let's say, do a row count or things like that. So I should be able to connect to this standby database here. So that's the reason why I need that. And then similarly, this one is 10.1.1 is for, for the ONS communication, right? So whenever you create a RAG database, those instances need to communicate. And the last one is the 6100. So that's the ONS traffic actually. And this one is for the traffic between the rack nodes and the SQLnet scan listener. That's the purpose. All right. So we did all that. Then we are going to, then we created the RAG database. And so now we are going to see what is the status. Okay. So let's go back. So here, let's say we are in Ashburn. So let's see our database. So my primary database is running, right? And my rack nodes are up and running, all right? And these are the IP addresses. So let's go to Phoenix. And so here are the rack nodes, and these are the IP addresses, all right? So let's, so this is the IP address 10.1.198, 10.1.1.124. So you remember our spreadsheet. So this one we entered some dummy numbers here, but now let's update with the correct values. So 10.1.1.98 is this one, and this one is 124. All right. So let's enter. Just make sure that there is no space after this IP address, because then in that case, some of the commands, for example, this command, it creates a space between the IP address and the port number. So that's going to create problems. All right, so that's done. Then what is the scan, right? So there is a scan for the Phoenix database. So copy that. And so the thing to note here is this is a, so let me take that and put it into here. This is a scan name. So that's the one, that's a scan name. And then what we need to do is the rest of the things are valid. So now we can create some workload. And so that's the first. Let's so there we will create a batch connection. So let's create. All right, so that's connected to the bastion. Then let me open another window very quickly. And what we would do is we would connect to, we already have the service created for this one. So let's connect to standby node, and let's create a service there also, right? So let's go take this window, let's put it to the left side to indicate this is on the Phoenix side, on the west side. Is that? So, yep. So now you can see it is connected to the Phoenix rack node, all right? So now let's create the service there. Again, the service name is same, just the instance names are going to be, this is preferred is I81. So there, what are the instance names? Let's check the instance names. So PS minus EF rep P1. So the instance names are still same IAD because they are tied to the database name. So let's go here and let's look at the standby unique name. All right. See, this is the unique name. So now we got that. So let's go back to now. What we'll do is we'll just create the standby that sales.tac service on the standby. So just copy this and this here. Already in the Phoenix terminal and is that. Yeah, first time that one does not exist. So we need to copy all the way up to this single double quote line. So it's going to create the service. So see that it's running. Okay, cool. So now what we can do is this. We can go to, we need to connect to the standby node 2. tnsnames.ora file we already created in the Bastion. List PDBs. Let's just test this. It's all working. Here is that. Okay, that's working. So this is we are connected to the primary database. All right. So that's C. Then the list DB services, we don't need to do that. We created the schema. We created the, we can create the workload. So we can just go there, take this and paste it here. So now we are running the workload on the primary database. See, should start any second. All right. So now it shows you the transactions per minute and a second. Now, if you want to query the number of rows, so we can create another Bastion, another bash window on the Bastion. So let's do that. All right, now I can just copy this and see. Say 122,000, 123, and so on. Okay, now the next thing I want to do is just get out of this and I can connect to the rack node 1. So this is the primary node 1, right? So I just want to show you some things. So let's go to the rack node, paste it here, and so do this here. Oracle. So connect with Oracle. Now you can see DGMGRL sys DBA show configuration. So there are two. So it says it's primary and this is the standby database. Now I can say switch over to this one, right? It is very easy to do that. All right. So let me show you that. I can do this using the UI also. So I will show you that, but Thought I will show you this first. Okay. It's going to take about 2 to 3 minutes. So if you like to fast forward, you're welcome to do that. And while that's going on, what's happening to the workload here? So it is right during the switchover, obviously it has come down to 0. So another thing I need to, while that's going on, let me show you cat DNS names whatever. See this one here, we did not regenerate this. So actually, I need to regenerate that file. So this is the scan name actually. But what happens is, this is, okay, let me first do that. All right. So let's see whether the switchover has happened. Okay, connected to this. So the new primary is this one, which is good. Now, just to complete that. Okay, good. So it's now the primary is this one, right? So if you want to be sure about that one, we can connect to the standby node 1 and check that out. Actually, we are already there. So in this window, right, this is the standby node 1. So let's sudo cf-on SQL plus. Yeah. So you can see show PDBs. So see that one, there's a sales PDB, this thing. Now, can I connect to this from this client, right? That may be your question. Now, yes, it should be possible, but the problem is this scan name, it cannot be resolved. So for example, you cannot, it doesn't know. So there is a different process. There is a different method to have that DNS resolver. We need to configure the DNS resolver to resolve this host name, right? The scan name. So until such time, what we'll do is I will show you that in a separate demo. But for now, if you want to do this, what you can do is you use the IP address. So for example, here, this is for the Phoenix. See this one? This is the scan IP address. So take one of the IP addresses. So go back to the spreadsheet, just plug it in to this input. So here, instead of scan name, right? Instead of scan name, you put the IP address. So then you go back to you need to generate too many windows here. So here. So now you see this one IP address, it is come here. So what you do is you copy this and go back to the bastion here and paste it here. So now for the primary, I got this one, but for the standby, I have the IP address because from the bastion on the primary side, I cannot resolve the actual scan name. So that's why I have to use the IP address. So now let's see whether we can run that workload, right? The CareBench workload. So now it's going to, okay, CD, swingbench, bin directory. So now it's going to actually connect to this database on the Phoenix side. Listener refused to. Why it has refused? Okay, let's go back there. Still standard database service minus D. What is the unique name? This one. Minus service sales.tsc. It is running on this one. So what is the problem? Let's see. The TNS names are over on this one. It's the one we have. First name is 10.11.253. That's a scan name. Listener refuse connections. Currently no, that doesn't sound right. It's working okay. So let's go back to oh, you know what? Yeah, that makes sense because we did not generate the configuration file. So you remember that swingbench uses a configuration file. So that's what we need to do. The correct configuration file earlier. So let's see. See this one. So here we have the scan name for the, so we need to regenerate that. So where is that? Here it is. So not that. Wait. So this is a configuration file. We need to regenerate that because now it has got that IP address. So let's take that and so now we got the correct configuration file. CD swingbench bin. Now let's run the swingbench again. Okay, the swingbench command is here. So this is the right. Is that? So now it should connect to the database on the Phoenix side. Okay, so it looks like it's working. Now, obviously, the throughput is not going to be same as what it was in Virginia side because the swingbench program and the RAG database are in the same region. Now, the swingbench is going across the network to Phoenix, and that introduces a lot of latency. So you won't see a whole lot of throughput, but this is just to demonstrate that. All right. So let's see. We should see the throughput going in a second. See, now it's happening. Now you want to do the row count. All right. So let's see the row count. Now, did we generate the TNS names.org? So let's go here. Let's get out of this. Okay, so actually I'm in the rack node. So let's connect to the second window in the So this is the bastion, basically. Now let's run this. Do we have the correct TNS name? Yes, we do have the correct IP. So now let's run this and see whether the row count is changing. It's going to connect to the Phoenix database and see that 141,000. So let's 141,193 customers. So let's run it again. And now it's growing. You can see that. Now let's get out of this. And while that's going on, let us do a switch over. Let's connect to the rack node again. Primary node. Okay, so let's connect to the primary node here. All right, sudo su minus oracle dgm glm show configuration. Okay, so it looks good. So now the primary database is Phoenix, and this is the standby database, the Virginia. So we can say switch over to IAD. Let's do that. What we will do is, now while that's going on, obviously, this is going to go down to 0 because during the switchover, all the connections will be drained out. So there will be no real throughput. So that's what you're seeing here. All right. So let's see what happens after switchover. Actually, so the database is already open on this side. Actually, it should, there will be some initial errors, but it should actually, see, now it's connected to this. Now you see automatically it starts taking the workload. So now it's connected to the Virginia database. So its switchover is completed. So that now if you want to again see the number of rows and all that, so you can actually, yeah, you can exit from here. Just log in from the batch inside. So row count, right? So pick the row count thing. The row counts. So connect to the bastion again here from this window. And then you run this. Right. So it's 145,000. So now it should go much faster simply because now we are running the client on the Virginia side and there is no latency. So you can see the throughput. Oops, did I cancel? Oh, because it ran for 5 minutes and then it closed. So if you want, we can just run it again. So just to see this one, this was a 5-minute workload. That's why it stopped after that. So we can now run it again. The throughput will start increasing, and we can just wait another minute and we can close this demo. All right. Now, while that's going on, I can also show you, you can go to the database in here. So I can go to this database, and there is a data guard association. So this is the primary database. Now I can go here and say switch over. So this is using the UI. I mean, you can do it using DGMGRL or using this UI. Both are exactly the same. There is no difference, right? So just want to show you that. I have not used the UI, but I could use this. All right, so let me go back to this. So let's see the throughput. It's so many transactions per minute. Now let's go back to here and see whether the rows are increasing. All right. Okay, so it's 153,565, and so many customers, so many orders, and so on. So let's just one last time. Let's do this. All right, say 156,000 now. Previously it was 153 and 106. So it's growing pretty fast. You can see 113,000 order items, 284, 292. So that's simply because we are running the client and the database on the same, in the same region, the same data center. So obviously the throughput is going to be high, and that's what is the best practice.